Emma, this is Anna, and this is Kyra. So as most of you probably know, every group had to get one of the 14 National Grant Challenges, and we got carbon sequestration.
So as Emma just said, carbon sequestration was our grant challenge. So we're supposed to develop a method of carbon sequestration. And carbon dioxide is one of the largest contributors to global warming. But the technology in place now to sequester carbon involves liquefying carbon in the atmosphere and injecting it into the ground, which is very expensive and, to be honest, like completely over our heads. So it's just not viable for a project like this. So instead of doing the typical methods of carbon sequestration, we decided to go for a more biological route, and we learned some more about biological carbon sequestration.
So biological sequestration. The soil beneath our feet is a natural way of absorbing the carbon, so we decided to use regenerative organic agriculture. Some methods include conservation tillage, no synthetic fertilizers, and cover crops. This is a more natural way without using chemicals. These techniques help for the mycorrhizal fungi to grow, which is very important to implement long-term sequestration. And we've also made brochures explaining exactly what regenerative organic agriculture is. And so Emma's going to pass those around to help give you more of an idea.
So how does the soil store carbon? I didn't know that the soil was a natural way of absorbing carbon until we did this project. So the soil stores about 75% of the carbon on land. The ocean is the other big carbon sink. And the process starts with the entire carbon cycle, which mostly begins with photosynthesis as plants. They go through photosynthesis and incorporate a lot of the carbon, and they respire a small portion of it back into the soil or the atmosphere. Carbon is also added to the soil as organisms die and decompose, plants, animals, and it's also part of soil minerals that are a vital part of soil health. The clay in our soil actually makes it easier to store carbon. I'm sure a lot of you know that there's a lot of clay around here. So does carbon stay in the soil? So it can be released very quickly, or it can be stored for a long time. Soil that's not very healthy, that's tilled a lot, goes through a lot of agriculture, it releases carbon very quickly. And our goal is to keep it in the soil for a long time, so that's where regenerative organic agriculture comes in. So we plan to do a community garden with the goal of sequestering carbon, as well as teaching the practices of regenerative organic agriculture. It will make our community cleaner by absorbing more carbon. And like I said, it'll be an educational opportunity to teach our community about the benefits and practices of regenerative organic agriculture. So we hope that people in our local community will adapt the practices. The practices include synthetic fertilizers, no synthetic fertilizers, so we'd use manure or compost, conservation tillage, and we'll get our soil tested every year to track that soil health.
Okay, so as Emma just said, in all of the things that have to do with the regenerative agriculture, it's the use of non-synthetic fertilizers. So in our community garden, we're not going to use any synthetic fertilizers because they're known to increase the microbial respiration of carbon dioxide, and they suppress the growth of mycorrhizal fungi, which are play an important role in long-term biological carbon sequestration. So instead of using the synthetic fertilizers that you can go and buy at Home Depot or whatever, then we're going to use compost, which we would include in our community garden, as well as different biological fertilizers like manure.
And there's also conservation tillage. It's not widely used, but it's still a regenerative organic practice. It's typically kept to a minimum because if you till too much, it can break down the soil and deplete the mycorrhizal fungi, which you really need. So by reducing or eliminating tillage using cover crops and crop rotation, that helps to ensure that the land will not be bare, and it also minimizes erosion losses while incorporating carbon-rich ingredients.
So this is a location we picked for our community garden in Beehive. It's right behind the modulars, if any of you know what that is over there. It's in a large open area that's not really used by the school for anything, And it's a big enough area for a garden, but it's also easily accessible by students because most of the work on this garden would be done by students and volunteers.
This is a layout of our proposed garden. It's a 50 feet by 50 feet field with 8, 10, or 11 by 22-foot plots. We have different plots to allow for crop rotation, which is a part of our regenerative organic agriculture. And there will also be a location for the beehive nearby.
So you might be wondering by now, why are we going to put bees into our garden? Well, by implementing a beehive into our plan, our garden is going to be much more sustainable and long-term lasting. So if you look in your brochure, you can see a list of crops that we plan to grow in our garden. And all of these crops are bee-friendly and commonly known as pollinated by bees. So as these bees pollinate all these plants, the crops are going to grow more and there's going to be higher populations of them. So the bees also lead to healthier plants as well as a natural supply of honey that can be used in the school by the community. So a big thing you might be hearing in the news lately is about colony collapse disorder, and it's an issue threatening the worldwide population of bees. And as you can see in this graph, it shows that up to 31% of the bees are dying in the winters, and that's like from numbers from beekeepers. And so colony collapse disorder is characterized by a decrease in the population of mature bees in the hive, leaving only a queen, and it leads to a non-functioning hive. So this might be an issue that we could come across in our community garden and beehive, but there's been doing a lot of research to fight against colony collapse disorder. And a big thing about the colony collapse disorder is related to the varroa mite, and they're thought to have an effect on the colony collapse disorder. So the varroa mite latches onto a bee and it weakens it by sucking some of the stuff in their blood. And so there are some medicines that are applied into the hives so that it treats the bees with this medicine so that they become resistant to the varroa mite. And we visited a bear bee care center and they told us about some of the research that they're doing and how some of those technologies could be applied into our beehive.
So one of the things we mentioned earlier was that we get our soil tested every single year. So we took a soil sample from the location where we plan on putting our garden, and we sent it into the North Carolina Department of Agriculture. Well, it doesn't.
Freshmen, sophomores, and juniors who are presenting posters, if you have not switched with your partners yet, please do so at this time.
If you're leaving me very quietly, please go ahead. Sorry.
Anyway, so soil carbon is very hard to get tested. It's expensive and time consuming, and we don't have the resources. Sorry.
No worries.
With all that leaving.
Go ahead, sorry.
So we can't get the carbon in our soil tested, but there are other measures of soil health, such as pH, phosphorus index, and potassium index, which the North Carolina Department of Agriculture told us.
Love the action shot.
Yeah.
Nice.
So phosphorus is important in root development, crop maturity, and seed production, and potassium aids in water absorption and retention and encourages strong plant growth. So these were the results of our test. Our pH was well below the optimal range. Potassium index was way above it, and phosphorus was way below it. So not too great, but we hope that by using the regenerative organic practices and getting it tested every year, we would see those numbers trend more towards the optimal ranges.
Okay, so on April 28th, me and Kyra went to visit the Bear Bee Care Center at Bear Crop Science in RTP, and we met with one of our mentors, Dr. Becky Langer-Curry, and she showed us around the center, and she showed us all about the educational tools that they have there to teach a lot of the people in the community about the positives of having bees and threats that are related to bees now. Let's see. So they're doing a lot of research pertaining to the varroa mites that I talked about earlier and the colony collapse disorder. And they also teach a lot there about how to handle beehives and how to handle bees and like why they're important. So it was a really helpful opportunity for us to go there and meet with her and also see a lot about this.
So our garden will sequester about 0.2 metric tons per year. Doesn't seem like much, especially when compared to that big number up there that Raleigh currently produces about 5.4 million metric tons per year. But you have to think it's only a 2,500 square foot plot of land, which is not very big. And like we said, we hope that we'll teach the community about our regenerative organic practices, and hopefully that more people in the community will start using these practices and thereby sequester more carbon.
So we plan to implement a community garden with good sequestering methods to help teach the community to as well do these methods on their own and learn just how the bees help our community, especially with the carbon and providing fresher air and foods. And hopefully they'll do this themselves.
So we have like sort of a skeleton of a beehive that would go in our garden. It's 10 frame length straw hive. It's pretty big.
Made by Amazon.
Yes.
And so it's just a frame where you would have all the bees, and this is where they would create their honey. So yeah, that's really cool.
And also over here is a sort of schematic layout of our garden. We have a bigger picture of it on our PowerPoint. So, any questions?
Does anyone have any questions? Yes.
Are there any other places in the community or state that actually use this sequestration, this method?
It's not very widely used currently. A lot of these practices are kind of new. And a lot of the research we did was also talking about using it on a larger scale, like for farms, which also is not used very much. I think it could be very beneficial though.
Yes.
It should be used.
Thank you. Yes.
Your soil sample showed you were out of range in a lot of areas. Name a couple specific things you would do in the garden that might help bring it back towards the correct range.
Well, other than the practices we said, like natural fertilizers, no synthetic fertilizers, I remember the Department of Agriculture suggested we use lime fertilizer to help.
So lime from a bag would be okay.
Yeah, I think that would, honestly, the indexes are pretty off right now. It would be hard to get started.
I mean, the potassium, I think, was really high.
Yeah.
Yeah.
So I don't know how you reduce the potassium, but it's interesting to see how.
We're hoping that as our garden gets started, and then as it grows more and becomes more healthier due to all of the other practices that we're going to try to implement, that it would reach more of a baseline level.
And this land has never been used as a garden before. It's just sort of there, so hopefully that would help.
So it'd probably take many cycles.
Yeah.
You mentioned small impact as compared to the size of Raleigh as a whole, but also that it was a small area there. Would there be a next step plan that would expand that could have a larger overall impact on the Raleigh area? How might you do that?
Well, like we said about the education, hopefully we spread it around. We could hopefully encourage more schools to do this, because one thing we had thought out was funding for this kind of thing. There's actually a lot of grants that are specifically for gardens at schools. So that's one thing that you could.
So if we ever decided to put this actually into effect, and there's a lot of grants that you could apply for to get the money, and then as say our school actually does it, then other schools and businesses in the area could follow suit.
Anybody else? Any questions around? Yeah. Let's give them a round of applause. Good job. Well done. If y'all had